All right, so I'm going to go ahead and do version A. I don't mind if you're not working on this with me, but I need you to remain quiet. Desmos is on this computer here if you want to check it. So all right, so again, this is version A. So number one, and this is something I was saying yesterday, that if the problem does not have a log in it, at some point you're going to introduce log. If the problem does have a log in it, at some point you're going to try to get rid of that. Okay. So this one, to get the whole reason we have logs is to get the exponent down in front. Okay. And we're allowed to log both sides if we have something that has an exponent, the 2 has an exponent, and it's only allowed to have one exponent and nothing else. It can't have something in front or something past the exponent. Okay. In this case, it's ready to go. Okay, because it's a 2 holding on to, even though there's more than one thing up there, it's holding on to that one exponent. So what we're going to do is we're going to I sneak in a little log in front of both sides. Okay, a lot of people I've seen just put log on the one side. The only reason I'm allowed to put a log in there is because I'm doing it to both sides. Okay, when I log both sides, that makes the exponents jump out in front. Thank you. Okay, so then we get that. And then what I'm going to do is I'm going to divide by log of 2, get rid of this. And it's weird, as soon as we introduce a log, our next step is to try to get rid of it. A lot of people are trying to say that log of 32 divided by log of 2, like the logs cancel out and then it's 32 divided by 2. It's not. Okay, you have to put this in the calculator. Yeah, so you did guess and check. Okay. Yeah, I mean, personally, I think log is the easiest way if you understand the logs. Okay. If you've done some awesome creative math and you got a correct answer, then that's awesome. Okay. Okay, so what is log of 32 divided by log of 2? I don't have a calculator. Someone's going to have to help me out. 5? Okay. So a lot of people would think that that's something different, and I have no idea what it is unless I use my calculator. Okay, and that equals 5. So now I've turned this into an easier Algebra 1 problem. So I got 3x equals 15, x equals 5. And just so we are clear, if you had the B version, the other version, you should have gotten the same answer. Okay. Any questions on that? So again, we're logging both sides to get that exponent down. Okay, so number 2. Number 2 has logs in it, so our goal is to kind of get rid of them, and the way we get rid of them is translating it. Okay, so we need to get the logs together, which they are. They're on the same side, and then we have to write it as one log. So a lot of people don't realize that when I say write as a single log, and this is a skill that you'll show on the test, I mean write log once and then tell me what's going on. If there's a minus up here, that tells me that there's going to be some kind of division in this log. So as soon as I see a minus up there, I go ahead and make a bar, try to figure out what's going on. This x is a positive, is a positive log, so that's upstairs, and this is a minus log, so that means divide. Okay, so we have to write that as one log. We spent a whole week trying to build that skill of how to write as one log for this type of problem. And then to get rid of the log, we translate it. So I say log and you say it in the other form. When there isn't a little number there, it's a 10. 10 puts on the magic hat and becomes big and then becomes equal to this thing that was once a giant to it. Anytime we have a number or anything down here in the bottom, our first step is to get rid of that. Okay? So we're going to get rid of that by timesing by 2 on both sides. So even if there was a variable down there, we would do that first. So 2 times 10 raised to the first is 20. And there's our solution. Again, if you had version B, number 2's answer should have been 20. Okay. So we have logs. We got to get them as one log and then translate. A lot of people are kind of getting stuck on this translate part as far as remembering that that's what we got to do. The whole reason we make it into one log is so that we can then do that. Okay, number 3. So looking at number 3, right off the bat, I realize there's no log in it, so I'm going to introduce a log to get those exponents down. And once upon a time, in mathematical world, when people were trying to do these problems, they realized that they needed some technique to get those down, and that's when they invented the logs. Okay? So E is holding on to an exponent, and the other E is holding on one exponent. There's nothing outside, so I'm ready to log both sides. Because it's an E, what do you think the textbook, if we had one, would suggest you use instead of log? ln, okay, natural log. So you can use, it doesn't really matter. I can use log or I can use ln. The only difference is what button you push on the calculator, okay? You could actually use ln on the other problem. Does someone have a preference of which type I use? Okay, give me direction here. Log, okay. It really doesn't matter if I use ln or if I sneak in log here. It just means what button do I push on the calculator. Okay, log of E, so that means that that exponent in front is going to jump out. And on the other side, same thing, 2x minus 4, log of E. Okay. And then the weird thing, again, as soon as I introduce logs, my goal is to get rid of them by dividing them. So I'm going to divide both sides by log of E. And an interesting thing happens on this particular problem because they both just cancel out. Okay? If I were to type log of E, divide by log of E in the calculator, it's going to give me what? 1. Okay? And then 1 times anything is just that thing. So that means we're left with 5x plus 2 equals 2x minus 4. I'm going to subtract 2x from both sides. We get 3x plus 2 equals negative 4. I'm going to subtract 2. 3x equals negative 6. Divide by 3. X equals negative 2. How could I check this? Bless you. So I could check this by plugging it in. I could type in E raised to the 5 times negative 2 plus 2. Hit enter. It's going to give me some ugly thing. And then do the same thing to the other side and make sure those 2 ugly things are equal. Okay? We feeling a little better about this stuff? Okay? It's nice to have such a good teacher. Number 4. So 3 log of 2 plus log of x equaled log of 2 plus 3. Okay? So when we have logs, we have to write them as a single log. Before I can write this as a single log, I have to get them all on the same side. So that log of 2 is kind of bugging me. I need to move it over. So I'm going to leave, this side is going to stay the same. So I'm just rewriting it. But I'm going to bring this over to the other side. And what happens when I bring it to the other side? It becomes negative. Okay? So I rewrote this problem so that that was on the other side. If this was a problem I was writing down out of a book, okay, that's how I would have probably wrote it on my paper to solve it. And then I got to write it as one log. And there's a couple things that throw us off here. First is this number in front, okay? And I see that there's a negative involved. So as soon as I see a negative involved, I go ahead and I make my bar there. Okay. The 3 in front, where does the 3 in front go? It is. Well, yes. You're fine. Okay, so what do we do with that 3? So, okay, it becomes exponent. Some people want to write it here, but that's wrong because that says that there's a 3 in front of every log, which there isn't. So what we have to do is I have to kick that 3 out and realize that it's part of that 2. Okay? That log is a positive log, so that means it goes on top. This is a positive log, so that means it goes on top. This is a negative log, so that means it goes on the bottom. I don't care how ugly the thing is that the log is holding, that 2 to the 3rd x over 2. As soon as I have it as one log, I can translate. So when there isn't a number, it's a 10. So I'm going to go ahead and translate this. 10 to the 3rd equals this junk. 10 to the 3rd equals this junk. When there's a number on the bottom here, this number is going to get multiplied to get rid of that. So that's gone. So 2 times 10 to the 3rd is 2,000. And then I'm going to divide that by 2 to the 3rd. Get rid of that, and I'll get x equals, I don't know what 2,000 divided by 2 to the 3rd is. It's 2,000 divided by 8. Maybe you can help me out here. 200. Anybody have a calculator? 250? So we get 250. So get the logs together. That's what we did in our first step. So move that log over. Write as one log. And then translate. Yeah, absolutely. Number 5. Six raised to the 2x minus 10 plus 7 equals 43. So this is the circumstance where I say that we're going to log both sides, but before I'm allowed to log it, that 6 is holding that exponent, but there's something on the outside that's not allowed to be there. I can't log this side with that other thing there. What is that other thing? The 7. So I got to get rid of that 7, and basically all I got to do is subtract 7. That's 36. Okay, and now I'm ready to log because that 6 is just holding one thing, even though there's a bunch of junk in there, one bag of junk. And now I can sneak in my log in both sides, which makes that 2x minus 10 jump out in front. Log of 6 equals log of 36. Divide by log of 6. We get 2x minus 10 equals, and again, don't just assume that you can do this in your head. Okay, log of 36 divided by log of 6. I can't do it in my head, even though I think it's 2. Okay. But I'm like the smartest person I know, so, but I would use my calculator. So then it turns into an easy algebra 1 problem, plus 10, 2x equals 12, divided by 2, x equals 6. Okay. So get the thing that has an exponent by itself, log both sides, and the weird thing about when you log both sides, as soon as you log it, your next step is to get rid of the logs. Number 6. Number 6 is easy. Oh. Number 5 was easy. I hate to say it, they're all easy if you know what you're doing, but they're not easy to figure out. Logs are tricky because we've never worked with them before this year. Okay, so when students are asking for help on this, I would tell them it's just like number 4. Okay, we have logs. We have logs on both sides. When you have logs and you have logs on both sides, you got to get them together. So my first step is I basically rewrite the left side, but I'm going to move over. I'm going to move this guy over. So I'm going to rewrite this whole problem with that moved over. And when I move it over, it switches signs and becomes a negative. And then everything else stays where it was on the left or the right side. Some people, when I saw them doing this, they wanted to move the 3 over. Okay? No, we don't. The 3 is not invited to the party. We need to have that 3 on the other side. We just need the logs on one side. Now that we have all the logs together, now we can write it as one log. So I write log base 2, and I'm going to go ahead and put a bar here because there's a subtraction. And anything that's positive goes on top. This is a positive log. This is a positive log. So those two things will go on top, and it's multiplication. And that 10 is going to go on the bottom because that was subtraction. Again, I don't care how ugly that thing is that the log is holding, that x plus 3 times 5 over 10. I just want it as one log, so now I can actually translate. So I translate this and I get 2 to the 3rd equals x plus 3 times 5 over 10. Some people want to distribute in that 5, and that's totally fine. I personally wouldn't distribute in that 5. I would go 2 to the 3rd. I'd get rid of the 10. How do I get rid of the 10? Times by 10. So whatever's down there, I'm going to times by 10. So 10 times 2 to the 3rd, I think, is 80. And then to get rid of that 5, if you're being multiplied by 5, to get rid of that u, I personally wouldn't distribute it. It wouldn't be wrong to. I would divide by 5. Just a different way. Okay. If you distribute, you're going to get the exact same answer. 80 divided by 5 is, what is that? 18? 16, thank you. 16. And then subtract 3, and x equals 13. Okay. If you distribute that in, you're going to get the exact same answer. Most of you actually prefer to distribute that in, but that's just another way of doing it. Any questions? Did that help? So something I want to point out, or say, I should say,